What up, everybody? This is Mr. Stan coming at you with another physics video. And this time we're going to examine the problem of somebody pulling on a box at an angle. Okay, so a 100 kilogram box lies on the floor. Mr. Stickman tries to pull the box up with a rope. He pulls with a force of 300 newtons and at an angle of 45 degrees. The box does not move. Write a summation statement and find the normal force and friction and force of friction. Okay, so he's trying to pull this box by pulling up at an angle of 45 degrees, but it's not moving, and we want to find the normal force and friction force for this. So first of all, remember that when you do summation statements, you have like your vertical forces, which are the Fy, and then you have your horizontal forces, which are Fx. However, this time we have him pulling on the box with a tension force, and the tension force is at an angle, so it's not completely vertical and it's not completely horizontal either. So the way we start this problem is by breaking up the tension force, right, where he's pulling on the rope, and breaking it up into what we call horizontal and vertical components. Okay, and this is how you do that. Just imagine that the tension force is the hypotenuse of a right triangle. Okay, so we'll just complete the triangle right there. If we could find the um, horizontal side of this triangle, then we would find out how much of that tension force actually goes into the horizontal force equation, and how much, and then if we find the vertical side, we'd find out how much goes into the um, vertical forces equation. Okay, so in other words, the part of this is going to be the horizontal part that affects the horizontal motion, and the other part's going to be the vertical part. And the way you do that, right, without going into too much trigonometry, is this side would just be ft times cosine of 45, and you can put that in a calculator if you know a number for ft. And then the vertical side would be ft sine of 45. So here's what the free body diagram would look like. Okay, you have normal force from the ground pushing up in the box, and you also have a tension force. The tension force is pulling the box up and to the right, and so we'll have to figure out how much of it is to the right and how much of that force is up. You also have force of gravity, and you have the friction force, right? We know there's a friction force there because if there was no friction and he pulled on it like this, it would start moving. Okay. And so the tension force is 300 newtons, which means to find out how much of that force gets applied horizontally, it'd be 300 times cosine 45. And then to find out how much of it gets applied vertically, it'd be 300 times sine of 45. Okay, so let's start with the vertical forces. Right, so we're going to, again, add up all the vertical forces. If it's positive, if it's pointed up, we'll do positive. If it's pointed down, we'll keep it negative. So you notice you have the normal force is positive because it's up, the ground is pushing up on the box. The tension force would be positive because the string is pulling up and to the right. So that would count as uh, a positive vertical force. Okay, the only one that's negative is force of gravity. Gravity can be changed into its formula, which is mass times little g. Okay, and little g is about 10. The mass of the box is 100, right? And then Ft is 300. So if you do all that math, what you get is that the normal force minus 787 is equal to 0. Okay, so the normal force must be 787 newtons. So you'll notice what happens is by him pulling up on the string, the normal force no longer matches the force of gravity. Okay, so if you just let the box sit there, the normal force would be 1,000, just like gravity. But because he's pulling up on the string, the floor doesn't have to do as much work. Okay, now we're going to look at the horizontal forces. Okay, and this will help us solve for the force of friction. So again, with horizontal forces, anything to the right is positive, anything to the left is negative. And definitely the cosine part of this tension force is to the right because he's pulling it right and up, not left and up. Okay, so that'd be Ft times cosine 45. Right, and then the force of friction is to the left, so we'll make that negative. Right. And then we put numbers in, solve as much as we can. And once we do the algebra, you'll see that the force of friction has to be 213 newtons. Okay, so that is how you would do the box on a string.